Welcome, everybody, to the Manufacturing Matters podcast. Our guest today is Sam Rubin, President and CEO of LightPath Technologies. Sam joined LightPath in 2020 after leaving Thorlabs, where he oversaw its imaging systems division and all of Thorlabs' life science activities. Sam also founded and grew Thorlabs operations in China. Welcome, Sam. Good morning.
Thank you. Thanks, Dan. Thanks, Winn. Great to be here.
Glad to have you.
Our pleasure, sir. Thank you. Beautiful weather down in Orlando today.
Oh, it's great. This is a perfect time of year in Orlando.
Fantastic.
Rub it in.
Just down there for the A3 Business Forum, so I'm already missing it a little bit, but Jacksonville's not too bad.
Yeah, unfortunately, there's a different spring breaks starting now, so we're starting to get traffic again. But otherwise, it's a really good time in Orlando.
Beautiful.
Well, welcome from snowy New England, or at least chilly New England. Sam, just to kick things off, I'd like to put things into context a little bit and give our readers a little background on what LightPath does and where it sits in the value chain. Could you tell us a little about that?
Sure, absolutely. LightPath has been around for nearly 35 years now, most of the time as a component manufacturer, making optical lenses, different technologies over the years. Gradium was very well known back in the day until aspheric optics really took over and gradium was less needed. Today, later on, molded A-spheres were a big point for LightPath, especially in the telecom time. And in recent years, a transition towards more infrared optics, acquisition of ISP optics back in 2017 started that. Since I joined about 4 years ago, we've been transitioning more and more into infrared imaging, going in fact upstream into cameras, systems, overall solutions, more than just components. Today, probably about 30% of our business now is more solutions oriented, cameras, assemblies, customized subsystems, and 70% is still on components.
Wow. You mentioned the telecom industry. That was obviously much bigger on the turn of the century, or at least the boom was. We seem to be entering another boom now. Is that generating any new traction for you?
Actually, telecom is very, very small for us now for a couple of reasons. One is that molded optics are being commoditized, whether it's a precision molded technology that LightPath mastered and really spearheaded, becoming more available, or whether it's wafer level optics becoming available, and driving the cost even down. So just, it's a reduced industry just because ASP units, so prices per piece, are down significantly. So that makes the sort of overall dollar amount shrink. The other part is actually geopolitical. So LightPath used to be very heavy in telecom in China. And since the year 2019 or so, with the different restrictions on Huawei, there's been a very significant shift in the buying patterns in China by telecom companies especially. And so we, for example, lost nearly 20% of our overall revenue because Huawei, just like Hikvision and other companies in China, decided they no longer want or can even, sometimes was decided for them, purchase from American companies. And so a supply chain was built in China for a lot of those. And whether we like it or not, we ended up pretty much stepping out of the telecom. Today, it's less than 10% of our business.
I'd like to go back to China. Let's put some of that in the context. When you joined, obviously, something else is coming out of China. Obviously, you dealt with the whole COVID global pandemic and the supply chain issues in that as well. But it's actually a somewhat circuitous tie-in with the life science. But let's go with the when you started first. What were some of the challenges coming on board in that time?
Well, obviously, the challenge of figuring out how to run a business when you're working from home, or most of the people are working from home. I started at LightPath beginning of March 2020. I was living in Virginia. LightPath is headquartered in Orlando. I was planning on flying back and forth until the summer when I relocated with my kids. Yeah, you can imagine where this is going. I came down here for 4 days, met like 10 people, said, great, I'll fly back to Virginia. I'll be back on Monday. That was Monday 4 months later. So I started running a company when I only met 10 people in the company. It took me 3 years to get to our China facility, 2 years to get to our Latvia facility. In between, I found out that our management in China has been stealing money, surprise, surprise, and had to remotely, without being able to travel to China, fire the entire management teams there and rebuild.
Oh my.
So COVID
Talked about stacked troubles.
Yeah, yeah.
COVID, import-export controls,
The
IP stealing.
the silver lining
Gosh.
to that was that at least during that time, at least at the beginning of COVID, everyone thought that measuring temperature is really going to save us. And so we were making lenses like crazy for contactless temperature measurement devices. And so while we were suffering a lot, like everyone was, from the drawbacks of COVID and workforce and remote work, we were also very successful with shipping lenses. We were at the peak of it making as much as 4 million lenses a year on annual rate, pretty much for contactless temperature measurement devices. So it was a very interesting time.
Right. No, that was still using Chinese-based
And
manufacturing
that was
plants?
mainly in China. Yeah.
Okay. So when did they ever shut down your plant completely? I know
No,
it wasn't.
none of our plants were actually ever shut down completely. Our plant
Right.
in China, from the very beginning, because of the contactless temperature measurement devices, was deemed as essential. And so,
Beautiful.
whether we liked it or not, we actually had to work through the whole pandemic. I think they were hoping maybe to get shut down at some point, but thankfully we didn't. So we didn't have to deal as much with those kind of problems of supply chain and internal shutdowns. But of course, we had our share with the fraudulent management in China and everything going on around that. It happened to be around the same time, and of course, at the same time, a new CEO that simply can't even go and see his facilities. So fun time,
Right.
for sure.
You mentioned earlier that telecom has become a smaller segment in terms of your total revenue share, and you mentioned the difficulties with servicing fiber deployments in China specifically. Can you, for those of us who don't watch where fiber is going in around the world, what are the big regions that we're seeing where new fiber is getting installed?
So China was definitely a very big one back in 2020. So when COVID started, Chinese government decided, as part of their stimulus plan, to finance deployment of 5G across China. And so we were seeing an enormous demand from Huawei, our biggest customer at the time, for optics for that deployment. In fact, in hindsight, we can say that that was definitely overhype, and they were overstocking and getting too much. But at the time, it seemed like you deal with the information you have, and the information at that point was all the money is going to 5G. All run in that way. That's the way the Chinese government is going to deal with the stimulus for that. Later on, it started rolling out, obviously, in the US and in Europe. And there, some other trends, such as companies like what used to be 26, now Coherent, acquiring Finisar, Lumentum also. So the trends of consolidation and the very large levels there with the different transponders and telecom subsystem manufacturers led to a lot of insourcing of that optics, which really pushed companies like us out. But that is also really, probably a good segue into some of the changes we're doing at LightPath, because for that exact reason, or for similar underlying reasons, we've been shifting at LightPath completely from being a component manufacturer to more of a system provider.
Right.
In fact, I'd say that even before all of this started in the telecom level with those consolidations, we kind of felt it coming just by the fact that the entire supply chain of the industry is changing. And it's something I started seeing at 4Labs some years ago, which really kind of led me into going in this direction. And,
Right.
probably a good way to describe it would be to say is that 20 years ago, we were still a niche industry, engineers selling to engineers. Our customers knew more about optics than we did, right? And they would come to us, basically give a drawing and say, here, I designed a complete system, make a lens for it. And
Right.
then you're probably very familiar with it. The supply chain was really structured around that. At some point, there were probably 1,000 companies just grinding and polishing lenses
Right.
because the end customers were experts in optics. They were the Lockheed Martins of the world, the companies that knew everything about optics, would design the entire system, just needed someone to make the lenses for them. That has all changed. If we look at our customer base now, I'd say that 80% of our customers, and I mean it in a positive way, know less about optics than we do. So
Right.
the users of optics today, as the great thing is happening and the technology is being adopted and being rolled out into so many places and so many applications and uses, not everyone is an expert in optics. And to become an expert in optics, to design your optical system, you need a sort of 15 PhDs, $10 million in metrology, clean room, everything around that. And when optics is only a portion of what you're doing, you really don't want to make that investment in every segment, right? And so that created for us an opportunity. It sort of manifested in the telecom world in the other way around, right? Where there was a lot of consolidation of that supply chain. But in the infrared imaging, probably it happens, in a very different way, where today you don't see every drone company designing an optical system, right? Far, far from that. They don't even want to deal with the cameras. They just want the pixels. Where 20 years ago, anyone that would put a camera on a UAV or a drone or any unmanned system was designing the whole thing because it was again, the Raytheon, Lockheed Martin's, General Dynamics of the world.
So the shift sounds like it was on the demand side in knowledge. Is there also a concurrent shift at LightPath in your ability to you're looking further downstream yourself as well.
Yeah.
So you're developing new competencies and expertise in some of these
Absolutely.
designs.
Yeah, definitely. Some of it through acquisitions. We acquired Visibit Technologies only a few months ago, which was, I maybe even take a step back and I'd say back in 2020 when I joined, we did a completely strategic assessment of the company, understanding that underlying shift in the industry creates an opportunity, right? And an opportunity is a perfect catalyst and driver for change. And seeing that over the years, LightPath as a component company is having its margins squeezed, ASPs going down, it's going to be tough to stay that way. So a shift in the industry was a perfect setting for us to change direction ourselves. So that's great, but how do you do that, right? I mean, it's not enough to say, I want to be a subsystem manufacturer. Everyone wants to do more, right? Everyone wants to sell a camera for $5,000 instead of a lens for $50.
Right.
So there you go and you do an analysis of your SWOT and your strengths and capabilities and how do they align with it. And LightPath had a few really good things going for it. To begin with, as a technical team, it was far more than just lens grinding and polishing. Because over the years, LightPath developed the core technology of precision molding. It actually developed the entire equipment. So all the molding equipment, electronic engineering, mechanical engineering, software was done in-house. So this is very atypical for an optical component company. I came in-house and we have EEs, we have MEs, we have system level knowledge that you don't usually find. That was a gold mine, right? I mean, that was just perfect. Second is you want to look at, okay, now you have that, so you can get from A to B. You can get to the point of making sub-assemblies or even cameras, but why would someone buy from you? So here you have to leverage, okay, why are people coming to buy lenses from you to begin with? Well, they're buying infrared lenses from us because we make the materials. and we have some very, very unique materials. We expanded it further by
Right.
licensing from naval research laboratories some innovative materials that they did. Then we combine materials with molding, and we're able to do really cost-effective optics compared to assemblies made from germanium, zinc, or silicon, and so on. Once we understood that, we said, okay, if people are buying from us today optics, because with our optics they can achieve more, we can use that as our stepping stone to say, let's make a camera that can achieve more. Our Mantis camera that about a year ago we announced is a camera that can image all the way from 2 to 12 microns, which is, in the optics world, phenomenal. Usually you would have a camera that the optics for it is corrected for a certain waveband. Let's say 8 to 12 if you're doing long wave, 3 to 5 if you're doing mid wave. You could not, and we tested this, you could not, using existing materials, make an optical system that would image in focus, color corrected, temperature corrected, all these wavelengths. So our materials and the ones we licensed from NRL enables that. So we said, okay, if they enable that, and that's why everyone is getting so excited, let's do that. Instead of selling lenses to someone that would then go and build a magnificent camera, let us do the magnificent camera. And that was really our stepping stone into making more. And we were really afraid at first that customers would push back and say, why would I build a camera? Why would I buy a camera from someone making lenses? I mean, that's what I would say pretty much.
But what's your answer?
That's kind of the benefit of basically eating your own cooking, we might say, where you're actually having to design your own manufacturing equipment earlier on in the company's path, not just having the manufacturing base. I mean, design for manufacturability was something I really wanted to touch on with you today.
Absolutely.
And we're seeing that genesis because, I mean, it's common for optical component makers to now say, we want to become assembly makers.
Absolutely.
We want to grow our market share.
Yeah.
But the question is, do you have, as you've been saying, do you have all those pieces in place? So, and I do want to come back at some point later. You were mentioning about the application mix because we talked about the near infrared with Thor Labs. You were obviously a leader in life sciences over that whole division.
Yep.
So I'd love to hear more about that. But before we do that, so you've mentioned new materials on several cases. Is that the chalcogenide that we're talking about primarily?
Chalcogenide. We call it black diamond simply to make it easier to know. And to give it a bit of branding, but chalcogenide glass is exactly it. And sorry. These materials are phenomenal in a sense of providing technical advantages compared to existing materials. Again, I go back to being able to do color correction on such a wide range of wavelengths. But beyond that, these materials are also produced here in the US. So if you would call it synthetic glass, right? So we take a bit of this, a bit of that, mix it together, boil it, put it in a furnace, bake it, and out comes glass. Very different than, say, germanium, which is really a crystal that is mined mostly in China, and then the ore of it taken and grown into a crystal in an ingot in a crystal furnace, in a crystal growing device. And germanium, most of it comes from China today. And China, as a retaliation to a lot of the export restrictions, announced on beginning of July 4th to be exact, their intention of limiting the export, of putting export control in place for germanium. And so that played right into our hand, right? Because we've been working on this for a few years now. In fact, we're working hand in hand with Department of Defense. They've financed us with nearly $3 million in direct funding in the last 3 years, just for this, to go ahead in different funding mechanisms and so on, but to go ahead and finish development of materials and qualify them and build capacity to replace germanium. And in fact, it worked perfectly well, right? We're just about now ready this month, I hope still, to release the first of the new NRL materials, a material we call BDNL4. And it has a phenomenal performance to it because as opposed to all other infrared materials out there, it actually has a negative thermo-optic coefficient. So when temperature changes, the refractive index, the main optical characteristic of a material, changes with it. And usually it changes in a positive way, meaning temperature goes up, refractive index goes up, temperature goes down, refractive index goes down. This material has the opposite thermo-optic coefficient. So it does exactly the opposite of our materials. So for the first time, it will allow to actually passively compensate for temperature changes. It's a phenomenal characteristic.
It must have applications in space optics as well.
Absolutely. Space optics, airborne optics. So, when you have a drone or a missile that goes from ground level to 30,000 feet in minutes, temperature changes there.
Or in orbit, yeah.
Or in orbit, yeah. Today, the solution to that is active compensation. You build into those devices, motors and moving lenses to refocus them and compensate for that. To be able to do it passively is beyond, a dream. It's sort of, you don't need the motors. You don't need to have a person in the loops that would refocus it and compensate for it. Less lenses, less weight, less power consumption, everything, our designer really wants.
What I've understood, calicotronite, I don't want to say black diamond in this case, but calicotronite are difficult to work with. Is part of that investment that's been put into LightPath not only to grow capacity, but also to help address some of those issues, make it a little more easy to work with, make it a little more friendly for designers?
Absolutely. So, part of what we've developed over the year is leveraging our technology of molding into helping to fabricate optics from chalcogenide glass. And so we have a patented process in which we call it MPG, molded pregen. We take a piece of raw material and we mold it to near net shape, so that really, it's so close to the finished lens that when we're done with the molding, you just need to do a post-processing of like 5 minutes on it.
Wow.
So as opposed to taking a blank piece of material, putting it on a diamond turning and moving material for an hour to get to the final lens, you get this pre-generated blank. And you put it on the diamond turning machine, and it's so close to your final lens, you just need to really kiss it with the diamond turning tool to get it into perfection. And that significantly reduces the cost, as well as any handling, processing, and more. Sorry, the other part in it is coating developments. And chalcogenides tend to be softer than germanium and silicon. And so we have developed unique DLC, diamond-like carbon coatings that can be applied to it and are as hard as a diamond or very close to that, and add a whole protective layer to the front lens of a system.
How is this impacting the overall availability of infrared compatible lensing and optical materials?
Yeah,
I mean,
I think since the announcement in July, at first everyone was a bit skeptical on it and waited to see what is happening. Now, I think everyone realized it's for real. If you look at the published numbers of export of germanium out of China, it is down by nearly 10x. I mean, 7x in November. I didn't check after that. We see it also. There's basically, as far as we know, no export license being given by China to export germanium to the US. They export to Japan, they export to Russia, they export somewhat to Europe, but none to the US. And so now everyone is realizing it's for real. And we have, I'd say it's almost like a tidal wave of customers that are either redesigning their systems now or asking us even to redesign their system for them to use chalcogenides instead of germanium. So I hate to sort of be a bit arrogant about it, but we are at the perfect place right now from that point of view.
That just sounds like a factual observation. And you can certainly be proud of the company that you built. Sam, how is this going to impact the per unit cost from an end user's perspective? Are we still mainly where we're using Black Diamond to basically extend the infrared wavelength compatibility? So we're still adding features, but cost per unit pretty much stays the same, or will this? As cost per units come down, the spread of the technology and the adoption, as we've seen in so many other imaging modalities,
has something very interesting to it. To begin with, the raw material, the ball of glass, is significantly cheaper than germanium. But there are two things that go against it. One is, because germanium is so expensive, an entire supply chain of recycling germanium was built. And so every piece of scrap of germanium, powder from the polishing, everything gets taken and recycled, where it doesn't exist with chalcogenide. We are working now, we're starting to work with a group led by UCF here, University of Central Florida, financed by Americom, to develop the technology to recycle chalcogenide. Once that is developed and in place, and a recycling facility or capability is developed, that cost would get almost equal. The second is that chalcogenide has, in the final processing, slightly more work to do in coating. And so the coating layers of chalcogenide right now take one more extra step, which makes it slightly more expensive than coating germanium. There are different companies working on that, on the coating technology, and I'm sure that will come into place. So to begin with today, chalcogenide is pretty much equal in price to optics made of germanium. So there's no change there. Down the road, it could get as much as half the price. So it could help significantly reduce the cost. The second part is, today when you go to design an optical system, you pretty much have 5 materials to choose from. 2 chalcogenides that are vastly common by LightPath and other companies, germanium, silicon, and the zincs, 6 materials. The result is systems that have many, many lenses in them. We have an example of a published work that was done showing a 3x zoom that works both in midwave and longwave, using existing materials that has 21 lens elements in it. Because we are introducing now 9 new materials with different dispersions, with different thermal optic coefficients, with different CTEs, if you take that example of the zoom lens, you're able to redesign it from 21 elements to 12.
Wow.
So you have a 40-something% reduction in amount of lenses you need. But that is also a reduction in size, in weight, and an improvement in optical performance. Every surface loses a bit of power. If you have 21 elements, it's 42 surfaces. If you have 12s, it's 24 surfaces. You get much more power. So you can achieve today with our new theory.
Plus, you're losing out some of the active, elements, right, for the refocusing and adapting to environmental changes, which is why I'm kind of surprised that we're not already seeing, even a greater cost reduction at this point. I mean, that's a massive change.
The problem is that most of those systems, at least the complex one, tend to be in the defense world. And the defense world, nothing changes quickly. You have to go through an entire requalification.
Right.
So, for example, we're working today with Raytheon on a very large project that they have, where they've essentially redesigned a system to minimize the amount of germanium in it. We're now in the qualification stage. When that happens, we're talking about tens of millions of dollars of optics that will be made of chalcogenides instead of germanium. All this is 17,000 systems in the field that over the next few years are going to be completely replaced with the new optical design. Right. We went through that already in the F-35, where the infrared optics there was completely redesigned. There's no germanium in the part. Whereas the suppliers there, we make optics into that. There are many more programs like that we could probably speak for an hour just on those, where everyone is essentially working to try and redesign and at least minimize the amount of germanium.
if we could, let's pivot back, if you wouldn't mind, to the applications. First of all, for our audience, I feel like we're torturing Sam by keeping him on this show because he's coming over a cold, and you know,
over COVID, back to the great things coming from China. Yeah,
absolutely. But we're still going to keep him on a little bit longer.
No problem. I'm glad.
We're bad and evil men, and especially Dan. I just want to point that out. But so Sam, we've talked about telecom being a smaller segment. Obviously, we've talked about defense now. But what are the other application industry areas that you think Black Diamond and your
definitely
solutions are going to?
We're seeing a great drive now of thermal imaging being used in health and safety. So automotive is probably the biggest next frontier for us. And that is adding thermal imaging to cars as another ADAS, another driver assistance sensor. We're already fully qualified into one of the largest car companies, together with a partner company, a tier one, that is going to integrate a thermal camera into emergency braking systems of a lot of the future car models.
Wonderful.
In fact, Department of Transportation just a few months ago announced their intention of mandating this. They announced at the end of May an intention of mandating emergency braking system in all vehicles, and specifically requiring a significant improvement of nighttime performance of those systems. And in the fine text, they talk about thermal imaging as a potential solution there. Thermal imaging is great in a sense that it adds another layer of data. It gives you the temperature, so you can know if that big thing inside of the road, is it a boulder or is it a deer or God forbid, a kid waiting to jump into the road, right? But it's still much simpler than some of the more complicated technologies like LiDAR. Thermal imaging gives a black and white image. Black and white image, we know how to deal with. Car companies have been integrating cameras now for a few years. Many car companies already have cameras as safety systems. So adding another black and white, I'm oversimplifying it, but another black and white camera in is much, much easier for them than some of the newer, more exciting technologies there. So we're pretty confident that in the next few years, we're going to be seeing thermal imaging go into car companies. In fact, we have the one customer we qualified into is looking to expand up to 1 million vehicles a year within the next 5 years.
Wow.
For us, it's great. We're talking about something like as much as $40 per vehicle for the thermal imaging piece. So it's a very big chunk there. So that's one element. Second is fire detection. Firefighters, that has been led by Seek Thermal, one of our great customers, but there's the leaders there by far, have been integrating thermal imaging into their day-to-day operations. They call it TIC, thermal imaging something. Thermal imaging
camera.
TIC with a C, yeah. Now we're starting to see companies start to roll out thermal imaging as early fire detection. And our broadband Mantis camera is probably a leading technology there, because with lithium-ion batteries now, fires are starting very regularly. In fact, there's an article in Time magazine showing pretty much once a day a fire starts in a recycling plant in the US. All the toys my kids throw into recycling and leave the batteries in, when those lithium-ion batteries get squashed or heat applied to them, they burst into fire. And my kids don't leave the batteries. I taught them better than that now. But fires are becoming a major issue because of lithium-ion batteries. Our Mantis camera has a very unique capability. It can actually image the gases being emitted from a fire at a very, very early stage, even before a flame starts. And so we can do early fire detection that is much more than anything that was really looked at until now. And with this lithium-ion situation, we're sure that the thermal imaging or infrared imaging altogether is going to become a major element there.
Sure.
Many of those toys, the batteries are embedded systems. I mean, you couldn't get them out unless you took smashed it and took it apart anyway.
Yeah, absolutely. Or need to be at least aware of it, right? I mean, singing birthday card, you need to tear it apart and take the battery out.
Absolutely. I buy those for my daughter all the time, and it never even occurred to me to think that might be a lithium battery as opposed to something
Taking
else.
time bomb. So just to jump back to the automotive application, Sam, were we talking about the chalcogenic glasses there for the ADAS system?
Yeah, definitely. I mean,
The top C benefits of the new lens assemblies there are going to benefit automotive.
so an interesting thing in automotive is so two things, right? One is the whole optics has to be outside. You can't put it behind a windshield because that would transmit infrared light. So
Yep.
suddenly you have to deal with things that until now didn't have to be dealt with necessarily. And that is temperature, for example. An ADAS system has to work from minus 40 degrees Celsius to plus 70. That means the camera has to be athermalized, meaning it has to maintain focus at all these temperatures. If you're going to use germanium, it has a thermo-optic coefficient of 400 ppm per degree Celsius. That means that when the temperature goes from minus 40 degrees to plus 70, someone has to go outside and refocus the camera. That's not going to happen. Chalcogenide has thermo-optic coefficients that are in single digits, and our BDNL4 has a negative thermo-optic coefficient.
Right.
So we're able to develop back to completely athermalized systems. So a lens system that would be focused across those entire temperatures. Second thing is you have to deal now with harsh environment. So you need our DLC coating to protect the lens from, rocks flying or anything like that. You need to be able to even heat the front element to defrost it, right? Because the ice on the lens, while, maybe you would think, okay, I can see through ice. Well, infrared can't. Infrared gets absorbed through water or ice. So we developed a special technology for defrosting the front lens of those assemblies. So there's a lot of different things that have to go into that, weren't even thought of at first. We're all very happy to jump and say, yeah, great, thermal imaging can do that. Well, it can. But then to put it onto 1 million cars a year, there's a lot of other problems you need to solve along the way.
I know Tesla has wanted to design basically the LiDAR level out and just mainly go with imaging systems. So not going to ask you who your primary client is in that space, but it seems like it could be an interesting bridge.
Yeah.
Your technology into that.
I mean, our primary client right now is more of the traditional car companies, actually, out of Detroit, and not so much the EV car companies. But I think that's changing. I think everyone is waiting to see what will happen with the proposed rule by DOT. That would sort of dictate a lot of that. But in the meanwhile, there are a lot of many other places that interesting things are happening with that. I mean, you mentioned Tesla and their sister company, SpaceX, is deploying optical communication like crazy with their satellites. And Dan, you mentioned space earlier on as a frontier for optics. But besides the thermal imaging looking down, we're doing a great deal of optics in space today for optical communication between satellites with different companies, not even just one or such. And that's a very big deal. They're able to now communicate directly between a satellite that is over Brazil with a satellite that is over New York through line of sight optical communication. That's phenomenal, never even thought of. I mean, NASA is trying that with space, with the moon, of course, but to do it with 40,000 satellites in low Earth orbit is just unique.
Yeah, that's only going to grow.
Yeah, absolutely, and thankfully, we're thankful that those satellites have a short lifespan. So, so as opposed to a lot of what we've done in space in the past, which has been, let's build one spectrometer that goes on to one Mars rover, and it's great, and it's we're all very excited by it, but it's one, and it's one every 10 years. So this is now, we're working with companies that are launching satellites on weekly basis. And have a lifespan of 2-3 years. So it's a great commercial business for us.
I honestly had no idea that was the expectation for their lifespan, of just 2 or 3 years. What's the limiting factor?
It's actually they're launching them, as far as I understand, such a low Earth orbit that they're constantly being pulled into gravity. And so when you talk to those companies, they're also saying, we no longer need some of what you're used to when you worked with, Lockheed Martin to launch satellites that would be there for 15 years. We don't need space qualified. We don't need radiation hardened. We don't need all of those, which, are really tough. LightPath has done a lot of work on radiation hardening because they say, we're launching a satellite, it will be there for 3 years. So don't worry about those things because in 3 years' time, it will burn into the atmosphere. Now, there's, people are unhappy about a lot of other aspects of it, and that is light pollution from satellites and having so much space debris and so on. But yeah, it's definitely getting crowded up there.
Well, if it comes back into the atmosphere and they're small enough, then there's not a whole lot of debris. It's just some ash falling out of the ground, probably for the most part.
Yeah.
So it's kind of a self-cleaning, sustainable free space
in batteries.
But that is interesting because one thing we do have to make sure is that there's no toxic materials in them that when it comes in and burns in the atmosphere would cause any environmental damage. So the companies that are doing these low Earth orbiting satellite rings or mesh are very particular about it as far as we can tell.
Oh, it's good. Their heart's in the right place. Does the Black Diamond offer a different? Is that another competitive factor over standard?
Actually, Black Diamond wouldn't fit that perfectly because it's not really the most environmentally friendly in that sense. But those materials are actually more regular glass and not the Black Diamond. So those are silica-based glass, which can burn pretty well.
Right.
Yes. The world's full of sand. Yeah. That's for sure. Sam, we're nearing the end of your torture segment here. So are there any final points you want to leave us with before we all go back to making the world better?
For us, it's some really exciting times. I mean, we're off doing cameras now. We're off seeing our cameras being rolled out into so many places we didn't even think we would be at before. I mean, we're doing now with Lockheed Martin a major missile program, which, hopefully would land us as much as tens of thousands of camera systems starting less than 2 years from now. And that's an enormous step for my team. And my team has done an incredible journey over those 4 years. And I want to use the spot a second to congratulate them and to recognize them for what they've done. Going from selling 4 million lenses a year at average sale prices of $10 a lens or so, to selling cameras that are for $10,000, to solving problems of fire detection, of building things that will go on missiles, is a very long step. And this team mastered it and really led us down that path. So very exciting times here. A lot of great things going on.
And global digital communication from all locations.
Yeah, I guess you can say that we took our telecom use and just moved it up to space, instead of fiber.
Yeah. That's fantastic, Sam. Well, Mr. Sam Rubin from LightPath Technologies, I can't thank you enough for joining us today.
Thanks for having me. It's been a pleasure. And Dan, great seeing you. Winn, appreciate the opportunity.
Absolutely. Hopefully we can talk again soon and talk about more autonomous communications as well as the space comms, or autonomous systems, I should say, and space comms. Until that time, for all of our audience, thanks for joining us today. We're here on Manufacturing Matters. If you'd like to see some of our previous episodes or be able to watch Sam's presentation later on, go to manufacturing-matters.com. If you have any questions for Sam, please just go ahead and send them to us. We'll make sure we get them over to Sam right away and get some questions back at that. Or if you'd like to join us on any future episode, please just reach out. But until next time, thanks for joining us, and we'll see you soon.
Thank you.